Start.
Hello everyone, my name is Spoorti and my teammates are Rohit and Aditya. Today we are here to discussing about home automation system using IoT, which have built under Emertxe's IoT internship. First, we will see the slides one by one, and finally, we'll show the demonstration of the project. Contents of this PPT are: what is IoT? Hello.
Hello.
Screen ಮೇಲೆ ಏನೋ ಬರ್ತಾ ಇದೆ. Contents of this PPT are: what is IoT? What are embedded system? C++ language, about project screenshots, and conclusion. Now, what is IoT? Hello. IoT is basically Internet of Things that describes the network of physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over Internet. Next, what are embedded systems? An embedded system is a combination of computer hardware and software designed for a specific function. Embedded systems may also function within a large systems. The systems can be programmable or have a fixed functionality. Industrial machines, consumer electronics, agricultural and processing industry devices, automobiles, medical equipments, cameras, digital watches, household appliances, airplanes, vending machines, and toys, as well as mobile devices, are possible locations of embedded system. Next. The main topics that are covered in C language are basic syntax and data types, operators and arrays, functions and pointers, preprocessors under which header files and macros, storage classes, string. And few topics covered in C++ are basic syntax, classes and objects, constructors and destructors. Further slides will be taken by Aditya.
Thank you. Next, we have to see about the projects. First of all, we see the requirements of our projects, in which we use IDE Arduino UNO for the writing the code of, and we use simulations Pixemlang for execution. Next, we use the controlling device of IoT home using blinking app. Next, we have see the Arduino requirements. ID, temperature system ADC, LDR, serial tank, serial communication, Ethernet slide, blink-in IoT app. Next, Arduino interface is simplest device used in most of the application as feedback. Work just like diodes. Low energy consumption, longer life, smaller size. After switching makes it usable in a wide application fields like human lighting, remote control, surveillance, device, and many more. Next, next we have the Arduino interface is in which the R1 and D pins are connected using IC as ATMEGA3.
Start.
We have seen the Arduino, in which this is used for interfacing the LED. Here we have a 14 pin listed from 0 to 14. Here the pin R1 and D1 and connected. We use IC ATMEGA328. Next, Arduino. Here we see the syntax of the Arduino. Here is the pin mode. We have simply write the pin comma mode. Pin, the number of a pin whose mode you wish to set. Mode, input, output, or input, pull up. See the digital pins page from more complete descriptions of the functionality. It's written nothing. Note and the warning, the analog input pin can be used as a digital pin referred to as A0, A1, etc. Next will be taken by my member Rohit.
Thank you, Aditya. Like from this, we will go on interface of CLCD, which can be used for display ASCII characters. So most commonly used as a ASCII characters to display that we need to use that CLCD. So some customizations in symbols possible. So whatever the customizations for according to the end users can be implemented through these display systems. So what are the communication modes means 8-bit mode as well as the 4-bit mode can be applied to the interface for the CLCD device. Okay. Next, the interface CLCD actually looks like this. So this is the CLCD, and which will be having again the 14 pins. We need to connect with the pins. So I will just dictate what which pins we will need to dictate. Means again we need to detect pin this 11th one, which will be connected to the 5th pin, as well as the 12th pin, which will be connected as 6. So after that, ANC not connected. So PB1 9th pin and 10th pin. So this is the major thing which we which we need to connect with to display the content from the end users. So as Aditya said, these are the 14 pins, 14 from starting to 0 to 14. So there will be a ground pin. So again, we will be seeing those pins again here. So this is what the kit actually Arduino consists of. So with the IC. So this is the reset button. Whatever we need to reset means at that time we can reset it to this. So next, Arduino, the CLCD consists of liquid crystal underscore I2C, liquid crystal I2C, which will be having the address as well as the column as well as the rows. So what descriptions? Set the LCD address and number of displays, lines and characters in line. So syntax liquid crystal underscore I2C, address column, rows. So parameters, columns, number of characters in each line, rows, number of display lines. So this is the serial tank which will be simulated here. So this is the serial tank which we need to be connected to Arduino again. So this is the fins which how we need to connect. This is having a COM1. This is the COM1 means we need to configure that with the Arduino that it need to be connected to the Arduino kit. Okay, so COM0 photon Arduino. So COM0 will be here. So it will be configured with the COM1 photon serial tank. So it will be majorly detect to heater the high floater when whatever the floating value can be detected from here. So this can be configured with these values COM0 and COM1. Okay. So Arduino Blink, again we will be using the Blink app, is a full suite of a software required to prototype, deploy and remotely manage connected electronic devices at any scale, from personal IoT projects to millions of commercial connected products. So with the Blink, anyone can connect their hardware to the cloud and build a no-code iOS, which we can use to analyze real-time and historical data coming from devices. Okay, so and it will receive the important notifications and much more from anywhere in the world. So this is the Arduino Blink app. So Arduino Blink app description: send data in various format to virtual things. So what I mean in code we need to write like virtual write a vpin and the value which we need to provide there, and parameters vpin virtual pin number and the value to be passed. For example, we can consider blink dot virtual write pin ABC. This is the ABC pin to send the string value, as well as the 1 2 3 as to send integer value. So if you want to send a float value means we will be considered 12.34 as a float value. So if you want to send multiple values, means we can consider hello 123 12.34. This is all the data types we will be including here. So this is a major virtual write. This is the command we need to. This is the syntax we need to take care of. So when we come to the result analysis, we'll go with the one by one part. So this is the I said you. Wait a second. This is the CLCD device which we can detect, which we can display the things. So we'll be having again LCD to detect. So the pins we connected, LDR to automate the things. So this is the fan. So this is the automation system. So automation system. I just read out the things. So the light will on from PD3 var 03. This is a pin which will connected to whenever the systems like LDR things, it's go down, the brightness will be off. If it goes up, the brightness will be on. So if you want to turn on the cooler mesh, we'll be using the home automation blink app to turn on that. So as per now, the cooler is off. If you want to turn on that, we need to use blink app. So we'll be discussing later. So this is the major thing. Again, we need to connect to COM1, COM2. This is the serial port in the serial tag. We need to connect from this. Okay. So this is the major thing I need to consider. And again, we need to take care of this is this microcontroller board. We need connected Arduino Uno board, modules, spare parts. So spare parts are like this only, which will be connecting, which will be showing the temperature from here. So the code for all this means this is the code. So this is the code which will be again controlled from all the devices. So we'll be having controlled IOT device. The hex file will be given to that Pixel lab to monitor. So this is the code. It will be having a blank template ID as well as the home automations. Okay? And the authentication token. So we'll be having this. So this is the authentication token. So we'll be including these all Ethernet, SPI, Blink Simple Ethernet, and a Liquid Crystal I2C for the display for the display system. So I've written the so many codes here for the heater pin and the cooler pin. Okay, for the temperature reading. So in LDR CPP, you'll be having brightness control for the garden lights. Garden lights, we'll be having that. So our first requirement from the Emertxe is so garden lights inputs LDR sensors. So we'll be including that LDR sensors. So this is the LDR sensor. Okay. So we'll be having that LDR sensors properties again consisting that first it will be connected to the ID 5 PD3, that is the pin number 3. So which read the LDR sensor and based on the reading from LDR, where is the brightness of the LED. So I show you how to brightness will be turned on and turned off using LDR. So this is the LDR. You can use that. Okay. So we need to just get it off. So this is the LDR. It will be simulated here. If you turn off, it will be turned off. This is the thing. So after that, garden lights will be completed and the temperature control system. Blink IoT app will be using that. So what I will do is app. I will just mirror my mobile phone to show that actual thing. Just a second. So this is the home automation system. So in here, what we did means we need to go home automations. We turn off the heater button as well as the control button, cooler button. So this is the thing simulation. So it will show whatever the content we need to see. We will upload that hex file here and control it. Okay, I just this is the Blink app we'll be using here. So that's the thing. So after that, a cooler control system. As I shown you, cooler control system, we will be having that again. The cooler fan, which will be connected to the pin number 4. So this is the thing. Like we just play that video of mine simulation. So this is a project. If we pull turn on button, it will be turned off. Again, the cooler will go off. That notification will be sent to the release. So this is a simulation. So at the end, we'll conclude with. This is the serial tank which I will show. Need to again show it. Spells. So this is the serial tank which will connect again COM1. Either side, COM0 is connected to the fixed lamp and COM1 will be connected to the serial tank, and it connected means so we need to open that photo. So home automations we will be having in Blink app a cooler pin which is connected to the V0, temperature sensor V1 and heater pin V2 and volume V3, and the data type for the cooler pin always will be integer type, and the temperature sensor will be double. For example, 24.30, this is the double data type, so we will be including that, and heater pin integer and volume will be integer. So this is what all the home automations system will be consisting on Link app. And next, the functioning, actual functioning. We built the project by successfully by writing multiple lines of code on Arduino and using Pixel Lab Simulator for. So in whatever we did means in Arduino, I shown you all the codes which are consistent. And after that, we will be go on implementing the things, and we will get the Pixel Lab Simulator. In our IoT home automation system, we include the garden lights that function on LDR sensor, and the intensity of the light depends on the amount of sunlight saved. If there is no sunlight, the LED would switch on, and if there is a good amount of sunlight, the LED will go off. So this is the thing. After that, next we control temperature system, including heater and cooler pins, which would function sensing the temperature around. If the temperature would rise above 35 degrees Celsius, it will be turned off. The notification will be sent again in the Blink app. Blink app. Okay. So finally, we will control the water tank system where we had inlet and outlet valve. If the water level of the tank goes below 2000 liters, we will receive notification on Blink app that or that the water level is below 2000 liters, and the inlet valve will be automatically turned on. So that will be controlled in a serial tank. So this is the functioning of all the requirements that can be given in MXC technologies in a IoT internship, 1 month of internship. So this is the functioning, and I will show all the things in the simulations. So again, we will go on conclusion part. Finally, concluding, I would like to thank Emertxe for making this project successful, and I thank all my teammates for cooperating to build this project, and for their cooperative communication. And we are able to build IoT based home automation system and also control it using Link app. I showed in the Link app. So this is all the contents we are used in the like MXC home automation system. And thank you so much.